So how do we see the non-luminous objects? First thing is that light falls on an object, then object reflects this light, or you can say light ray or light rays. Not one ray will be there. There are lots and lots of rays. And then our eyes receive this reflected light. Our eyes receive this reflected light, and then the image is formed on the retina. Then image is formed on the retina in your eyes. So actually what happens is that we have eye lens which forms an inverted real image of the object on the retina. And then this retina has light sensitive cells, and these cells get activated upon illumination and they generate electrical signals. And then these electrical signals are sent to brain via optical nerves, and then the brain interprets these signals, and finally the brain processes the information so that we perceive the objects as they are. So where is it written in the book? So this thing is written in the first paragraph of chapter number 10 in your NCERT, and this is written in further information that I have told you is in chapter 11, next chapter, and it is written over there, starting from the last few lines of the first page and then continued on the second page. So this is from the first paragraph of chapter 10, and this information you have from last paragraph of first page of this chapter, which is page number, if I tell you, then the page number is 187 and 188. So you can read it, okay? I have not written this. So students, it is very important for us, as I have told you, that eye lens forms, so there is a lens in our eyes and it forms an inverted real image of the object. So here in this chapter we are going to study what kind of image is formed. So image can be real or virtual. So what is the difference between real image and virtual image? Real images can be taken on screen. They can be taken on screen, but virtual images cannot be taken on screen. Okay, so that's the major difference between the now the first instance that we see is mirror, right? We all have mirrors and we see our faces in the mirror. So what kind of images are formed by plane mirror? So
Virtual and erect.
okay, good. So plane mirror, what is the nature of image that is formed? So I'm interested in the nature of image. So I have this plane mirror over here, and I have an object over here. So this plane, so plane means this should exactly be a straight line. This should be a straight line. So let me do it. It's taking so much of time. So this is exactly the straight line. So this is what, and it is polished on one side, this mirror. This is exactly what the plane mirror is, and I have an object over here. So what kind of image I will get by the plane mirror?
Virtual and erect. Virtual and erect.
Okay, so the image will be virtual, the image will be erect. So the images which are virtual, they are erect, and the images which are real, they are inverted. Okay, then
Behind the mirror.
okay, behind the mirror. Okay, fine.
Same size of the object.
Okay, same size, yes. So we are
Equidistant.
okay, equidistant, yes.
Laterally inverted.
Same size, equidistant. Okay, and then we have laterally.
Laterally inverted.
Okay. So all these sort of so this is the characteristic of the image formed by plane mirror, right? Now we have spherical mirrors. Spherical mirror, so size of in mirror, the size of the object is same as the size of the image, and image is laterally inverted, and it is formed as far behind the mirror as it is. So this distance is same. Distance is u, this is v. So this v is equals to u. So this image. Okay. And the image is laterally inverted. So all these things are written on second page as you start. So second paragraph, page 141 of your NCRT. So open your NCRT, students. Now we need to have the laws of reflection. So light is reflected from the plane mirror. So what are the laws of reflection? Whether light is reflected from the plane mirror or light is reflected from spherical mirror. So spherical mirrors means they are part of a sphere. They are part of a sphere. So that is why we call them spherical mirrors. So what are the laws of reflection which are followed by the plane mirror as well as spherical mirrors? So the first law is that angle of incidence is equal to angle of reflection. So these are very important. Second is, so we want to angle. Second thing is that, so if suppose a ray is incident on this plane mirror, then this angle of incidence, so it will be angle of this is the reflected light, and this is the angle R. So angle of incident and angle of reflection are same. Next thing is that this incident ray, and this is normal to the mirror that I have drawn, so angle is between incident ray and normal, and this angle R, reflected angle, is between normal and reflected ray. So this was incident ray, this is reflected ray, and this is your normal. So all three of them must be in the same plane. So incident ray, normal, this is normal to the mirror, right, at the point of incidence. So the normal is at the point of incidence and perpendicular to the mirror.
Reflecting surface.
So incident ray, normal, and reflected ray, all three of them
Lie on the same plane.
So all three of them lie on the same plane. So here also you can see that on the blackboard plane, all three of them lie on the blackboard plane. So these are the laws of reflection which will be applicable to all kind of, so these are applicable to all kinds of reflecting surfaces. Whether it is plane or spherical. So these laws of reflection are very important. So I told you that you see your face in the plane mirror, but where do we have spherical mirrors at home? So you might have spoons. So see your face in the spoon. Spoon is just like spherical mirror. So you will see what kind of image you find on the spoon. So you have a spoon, so see your image on this side, and then see your image on this side, on the other side. So this side will act as a concave mirror, this side, and this will act as convex
mirror.
So, which is there in your book figure 10.1, the concave mirror and the convex mirror. Now we have some terms for these spherical mirrors that we will use. So first is some key terms. First one is the pole. So what's the pole? So this is my concave mirror. So it's just like the light is entering the cave. This is this sort of cave you can see. So what the pole is? So this is the center of the reflecting surface of this spherical mirror. So this point at the center, this point is pole, and I write this point as P. So that's my pole. So pole is the center of the reflecting surface. So it's center of reflecting surface of spherical mirror. So students, I hope you have understood what is this pole. So just like you have your spoon, so the spoon and this is your, suppose this is your surface, or this center is your pole. So this pole lies on the surface of the mirror and it is usually represented by P. So whenever you are studying this chapter, always you can keep a spoon with you. Okay, it will help you in understanding this image formation by spherical mirrors. Okay, so keep a spoon with you. Now we have the next point which is important, is center of curvature. So what is center of curvature? So as I told you that spherical mirrors are part of sphere. So if you complete this sphere, then the center of the sphere is your center of curvature. So this curve you have, so name itself is telling you center of the curvature. So center means center of this curve. So complete the sphere and then the center of that sphere is the center of curvature. So center of curvature is the point which is the center of part of the sphere. So again, it's a point, and if you want to write definition of it, you can write this, that center of sphere. So how do you get this sphere? So this sphere is actually this reflecting surface. If you complete this reflecting surface, you'll get the center of the sphere, and the center of the sphere is center of curvature. Okay. So we represent this pole with the letter P. We represent center of curvature with letter C. Now, third key term. So important thing is that, is C a point on the mirror? No, C is not a point on the mirror. P pole is a point on the mirror, but C center of curvature is not a part of the mirror, but it lies outside the reflecting surface. So this is your reflecting surface, so it lies outside. P lies on the reflecting surface, but C lies outside the reflecting surface. And for center of curvature, for the concave mirror, it lies in front, whereas for the convex mirror, so this is convex mirror, and this was concave mirror. So where do we have the, let us draw the pole and center of curvature for convex mirror. So the center of this reflecting surface is your pole. Now you have to complete this spherical surface. So it will become a sphere. And the center of this sphere is your center of curvature. So students, see that light will come from this side, light ray. Here also light comes from this side, because here is your reflecting surface. So here the reflecting surface is convex, here the reflecting surface is concave. So you can see that the center of curvature for the concave mirror lies in front. So this center of curvature lies in front of the concave mirror, whereas in case of concave mirror, convex mirror, it lies behind the mirror. So this is your mirror, so it lies behind the mirror. Okay, now the next thing is radius of curvature. Of course, if there is center, there will be radius also. So the radius is this is your radius. It is written by capital R. So that's your radius. So that's the radius of curvature. Now, what is this line that I have drawn here?
Principal axis.
Okay.
Principal axis.
Principal axis.
So this is a imaginary line. This is imaginary. So this is an imaginary line passing through the pole and center of curvature. So we have a line, this line, you can see here also this line, and this line is passing through pole and center of curvature. So how many lines do we draw passing through 2 points? There is only one line that can be drawn passing through 2 points, only one line. If you have 2 points, I ask you to draw a line passing through both the points. You will have only one line, and that line here is principal axis. So principal axis is imaginary line passing through C and P. So this P is pole and C is center of curvature. Now another thing about this principal axis is that it is normal to the mirror at the pole. So it is so principal axis is so it's a line, right? So it's a line and it is perpendicular to the mirror. Obviously it is passing to the mirror at pole. So this principal axis is perpendicular. So to the mirror at P. Sir, how is this perpendicular? See, one thing you need to understand, that in physics, as this is the reflecting surface, this point P, now I am going near to this point P. I am going near. So I was watching it from here. Now I am going near to this point P. So as I go near and near to this point P, this curve will become behaving like a flat surface. So when you go very near to it, so microscopic view will be this reflecting surface. At this point, it will behave like a line,
Plane mirror.
it behave like a plane mirror.
Plane
you can
mirror.
say. Okay. Second thing is that, so this is behaving like a straight line over here. So this straight line perpendicular to it, so it will be a sort of tangent over here. So this radius and this line, so there will be angle of 90 degree. So because the angle between the radius and tangent is 90 degree. So whenever we are making the ray diagrams, so we will be following these two laws. So you need to draw the normal. So how you are going to draw the normal? So suppose if here I have this light ray and light is going to strike at this point. So now how will you draw normal at this point? So first of all, you will draw the tangent at this point. So draw the tangent at this point. And now this is your center of curvature. So join the center of curvature with this point where the light is striking, the ray is striking the spherical mirror. So this is your radius and this will be 90 degree. So this is your normal. So now normal will be just joining the point where the light ray is, the incident ray is incident on the spherical surface. That point, join that point with the center, you will get radius of curvature, and this radius of curvature is always your normal. Why? Because at this point you will draw tangent and the radius is always perpendicular to the tangent. So students, this is how we draw normal. Here we need not to draw normal. This principal axis so will act as normal. So here this will be your angle of incidence, and now the same angle will be there, and this will be your angle of reflection. So these two angles are same. Let me draw this diagram again. Very important concept. So that's your concave mirror, and I have an object over here. So light rays from this object, they strike at this surface of this point. Now this is suppose your center of curvature. So simply joining this center of curvature with this will be your angle of incidence, because angle of incidence is between the normal. So this is your normal, this is also your radius of curvature, and this was your incident ray. So incident ray and normal is your angle of incidence. Now angle of incidence is equal to angle of reflection. So this is your reflected ray and this angle is R. So incident ray, normal and reflected ray all lie on the same plane, and angle I is equals to angle R. So these are the laws of reflection, and this is normal because if you draw tangent at this point, so that is what the surface will behave. This small surface over here, it will behave like a flat surface if you go very near to this, and it will be the part of tangent. This surface is part of tangent where this incident ray is striking. So that's how we draw the incident ray and reflected ray. So angle of incidence is equals to angle of reflection. Okay, so next key term that we have is focus. So we have, in fact, we call it principal focus. So why do we call it principal focus? Full name is principal focus because it lies on the principal axis. This is your principal axis. So this is your principal axis. So the focus lie on the principal axis, and all the parallel rays will pass through the focus. So you can see this ray was parallel to the principal axis. So all the rays which are coming parallel to the principal axis will pass through the focus. So this focus. So this is the center of curvature. So this distance was 2r, and this is midway. So this distance is, this distance is r, radius of curvature. So this is half of the radius of curvature. So this is r by 2. So that is where we have the principal focus. So these are the key terms that we are going to use while doing the image formation by the spherical mirrors. So we can also write this length as focal length. So focus is a point at point F. Now what is focal length? So focal length, so this was your pole P. So focal length is equals to FP, and that is denoted by small letter f. So students, focus is a point, whereas focal length, it's a length. So this length FP is your focal length. So r by 2 is your focal length. So very important concept. Okay. Now the next, another important term that we have is aperture. So all these are related with this spherical mirrors. So aperture of spherical mirror. This was also of focal length was also of spherical mirror. Focus was also principal axis of the spherical mirror, radius of curvature of the spherical mirror. So all these are related with spherical mirror, which can be concave or convex. So this is the diameter of the reflecting surface. So what is the aperture? Aperture is the, so you can see this mirror, if this lays down like this, like if you have a spoon which is we have some spoons which are circular. Okay, so the difference between this this concave mirror and convex mirror, what kind of spoon I am talking about? I am talking about the spoon which is so I need a circle over here. So I need a circle over here. Hello? 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 Okay, students, so you need the spoon which have a perfect circle over here. Okay, so you can assume this is the side view. What view is it? This side view. What will be the top view? If you see the top view, what will you see? The top view will be this circle. So this is the top view of this concave mirror. So this is top view. And the diameter of this, so means 2r. So that will be your aperture. So aperture is, so this will be a circle over here, right? There will be a circle. Top view, it will be a circle, and this distance from here to here, this is your aperture. Okay, students, so don't get it confused with this radius and diameter. So this is the diameter of the spherical mirror that we call aperture. So if you have a circular spoon at home, so normally the spoons are not circular, but there are some spoons which are of bigger size that we use little bit bigger size than normal spoon, and they have they are in the form of circle. So the diameter of that spoon means that spherical surface will be a circle. And because when you are talking about diameter is always of a circle. So this diameter is your aperture. Okay. So here the aperture is, suppose this point is M, this point is N, so this is your aperture. So aperture is equals to Mn. Okay. Now another important thing, students, very important thing is when you will draw ray diagrams, always you have some certain assumptions. You need to have these assumptions. So what are the assumptions? First assumption is that the aperture is much smaller, than the radius of curvature. Okay, so aperture was your Mn. So the Mn is, so the ray diagrams that we will make, Mn will be much smaller than R. Okay, so this is the assumption when you will make ray diagrams. So which spherical mirrors you are taking? So which spherical mirrors you are taking? You will take the spherical mirrors whose aperture is much lesser than R. Okay. Now another assumption is that this ray will be very near to the pole. The ray that I am drawing here is very near to the pole. So the incident rays are near, are incident near the pole. So near the principal axis, near the pole. So these are the two assumptions that we need to keep in our mind while drawing the. So this is written in your book. This is, you will find it in later classes, like in class 12, this will also be written. But yes, we take both these assumptions. Now the next topic is the image formation. Image formation by spherical mirrors. So now we know the key terms, and so for both the mirrors, we're going to see how the image is formed. So whenever you are asked about the nature of the image, three things you need to keep in your mind. First is real or erect, means real and inverted, or virtual and erect. And second thing is the position, how much is it. So first is the nature, real or inverted, real or virtual. Second thing is the position, means position from pole I am talking about. So you'll always measure the distances on the principal axis from the pole. And the third thing is the size, relative size, not the size, but the relative size of image. So whom I am comparing its size with? I am comparing its size with the size of the object. Okay. So these are the three things. So nature means real and inverted and virtual and erect. So these are the three things that you need to tell about the image. Okay. So we'll place the objects at different positions, and then we'll find so what can be the relative size. So if you talk about relative size, so the size of the image can be larger. So if it is larger, then we'll write enlarged image. If the size is same, then we'll write same size of image as object. Obviously I am comparing with object, or we can have the diminished image. So these two things are quite important, nature of image and the size. And then we will have numericals, finding the position of the image from the pole. Okay. So in your book you have activity 10.1, and then you have table 10.1 also. So activity 10.3 is very important. So the activity 10.3, we already know how to determine the focal length of the concave mirror. So that is there in activity 10.2. So 10.2, let us see 10.2 activity first. Students, you need to understand that you are not supposed to look at the sun directly, or even you need not to see the image of the sun in the mirror. Never do it, it will damage your eyes. So hold the concave mirror in your hand and direct its reflecting surface towards the sun. and direct the light reflected by the mirror onto a sheet of paper. So when you will reflect it on a sheet of the paper, so rays coming from sun and then reflecting on this. So this concave mirror, so all the rays will be, so all the, see, when the rays are coming from infinity at far off, so they're just like parallel lines. We treat them as parallel lines. When the sun is at such infinite distance, so all the rays will be parallel. So parallel rays, we know that if this is the principal axis and I have focal point over here, so all of them will pass through focus. So ray principal parallel to principal axis will pass through focus. So put your screen over here, put your paper over here. So keep on changing the paper, that is your screen, and when you will get a sharp pointed image, so that point is your focus. So move the sheet of paper back and forth gradually, very slowly, until you find on the paper sheet, you'll find a bright sharp spot of light. That is the image of the sun. And hold your mirror and sheet of paper for a few minutes. And for a few minutes you will see that the paper will start burning. And the distance is your focal length. So that's how you find the focal length of a spherical mirror from this activity. So what kind of image have you got here? The image was tiny, relative size tiny, and it was real and inverted. So it was real and inverted and tiny image. And what about the distance? This position from P. So it is approximately the focal length. Okay. Now we have a table 10.1, and in this table we have position of the object, position of image, then you have size of the image, and you have nature of image. So three things that I was discussing about: nature of the image, position of the image, and size of the image. So these three depends on where you have placed your object. So this is what you are doing. You do it. You do this thing only. You do this thing only. And these three things are about the image. So you place the object, you do it. And for different positions, these three things are different. So like this case we have studied that the sun was at infinity. So when the rays are coming from the infinity, where do we have the position of image? We have just seen it. It will be at the focus. And what is the size of the image? So it was it diminished?
Highly diminished.
Okay. So it was not diminished, it was highly diminished. And it was point sized.
Point size.
So, and what was the nature of the image?
Real and inverted.
Real and inverted.
When
Real
we
and
talk
inverted.
about the nature, so always the question that should come to your mind is, Can I take it on screen? Can we take image on screen or paper or cloth or any material? Can we take the image on any material? On any plane?
Yes.
If you can, if your answer is yes, then it's a real image. Then it's a real image. But if your answer is no, then it's a virtual image. So the image that you see in the mirror, can you take that image anywhere else? You see yourself in the plane mirror, okay, fine. But can you take that image at any place? No, you can't take it.
No.
But here you are but here you were taking this image of the sun on the piece of the paper, so which was your screen. So that is why this image is real, and real images are inverted. We'll do it. So real and inverted image will be formed. Now we will learn, we have already learned, but still let us rewrite some of the instances, how to locate the image, what's happened. So let us see some representations of the images formed by the spherical mirror. So if this is your concave mirror and this is your principal axis, and you have the object at infinity, we have already done that case, that and the rays which are coming parallel to the principal axis, then all of them will pass through focus. That's a rule that we need to remember while making the ray diagrams. So these are the how to draw ray diagrams. So we are learning to draw ray diagrams. So how to draw the ray diagrams. So this is the first thing. So this ray you can take to draw the ray diagram, the ray which is parallel to the principal axis. Okay. So where you will get the, to make the image, you need at least two rays, then only you will get the image. So this was one of the ray, you will take one more ray. So this is incident ray and this is reflected ray. Now you will get the image. So how many rays do you need to form an image?
At least two.
At least two
At
rays.
least two.
At least.
At least two incident rays. So the result is that the meeting point of the reflected rays will tell me the image. So which two incident rays I am going to take and how they are going to be reflected, this is what I am drawing, this is what we are learning. So this was the first case when the rays were parallel to, so incident ray was parallel to principal axis. So this way. Now let me take second case where this is a ray. Okay, so I'm drawing this for concave mirror, And for convex mirror, if you take, let us draw for convex mirror also. So this is your convex mirror. Now the incident ray will come parallel to the principal axis and it is going to pass through the focus. But where is your focus? So your focus is behind the
Mirror.
convex mirror. So obviously ray cannot pass this mirror over here. So now it appears if you join this line, first of all you need to join this line here and now extend this line. So this will be your reflected ray. So it appears. So how will you draw angle of incidence and reflection? So this is your focus. So you will have your center of curvature over here and so join this. So this will be your radius and this will be your normal over here, tangent, and extend this radius you are extending. So this will be your angle of incidence and this will be your angle of reflection. So this is your normal. So similarly here also this was your center of curvature and this was your radius and this was your angle. So this acted as normal and tangent. So tangent at this point, normal. So this was your angle of incident and this was your angle of reflection. So students, I need not to draw this angle of incidence and reflection all the time. You have understood it. Now the second case, so here they actually pass through focus, but here they are, so here the rays are converging, right? Converging. But here the rays are not converging, they are diverging, because the second ray, if you take, so this is the incident ray. So this is supposed to pass through focus. So now extend this line. So this is a reflected ray. So reflected rays are diverging, they are never going to meet. Okay. Now second case is when you have a ray, incident ray, passing through principal focus. So if it is parallel to principal axis, then reflected ray pass through focus, right? But if the incident ray is passing through focus, then any ray, so this is mirror, and any ray which is coming and passing through focus. So this is the ray, this is my focus, focal point, focus, and now the ray is coming, passing through this. This is my incident ray. Now what will happen? Again there will be normal, there's this radius, center of curvature, and then again laws of reflection will be there, and we will have the reflected ray. Okay, so this will be my center of curvature, this will be my radius, and this angle of incidence, this, because this radius is always perpendicular to the tangent, which is the, so this tangent is actually this surface, the direction, means it behaves like a flat surface over here, very very near to it. So this is your sort of normal, this is your normal. So always incident ray, reflected ray, definitely there will be angle of incidence and there will be angle of reflection, and these laws are going to be followed. So the point is that incident ray passing through focus, then reflected ray will be parallel to principal axis. So this is what you need to understand. So just reverse of it. If the ray is parallel to principal axis, it will pass through focus. If the ray is passing through the focus, it will be parallel. Then the reflected ray will be parallel to the principal axis. Now what will happen if you have a convex mirror? So convex mirror, the focal point is behind the mirror, and then this is your, so now the incident ray will be coming such that it is going to meet this focus. So it appears to pass through focus. So then it will be parallel to the principal axis. So if it appears to pass through focus, it will be parallel to the principal axis. Now, so these rules are quite simple to understand. Now, incident ray passing through C, passing through center of curvature. So the incident ray is passing through center of curvature. So this was your focal length and this was your center of curvature. So if incident ray is passing through center of curvature, then it will be reflected back. Why? So if it is coming in this direction, it will be reflected back in the same direction. So here, what about angle of incident and reflection? See, the center of curvature, you are joining the center of curvature. So this was your center of curvature here, and you are joining it with the point where the incident ray was touching the spherical mirror. So here, this is your normal. Okay? So this is your normal, this is your incident ray, this is your reflected ray. So all of them along the same line. So that is why here angle of incidence is equal to angle of reflection is equal to 0. So that's this case. And now if we take for the convex mirror, then this is your focus and center of curvature, they are behind. So rays appear like they're passing through the center of curvature. So they will be reflected back. So here in this case also angle of incidence is equal to angle of reflection. And so now the fourth ray diagram. What will happen if the incident ray obliquely to principal axis towards the point P? So that's the case. So now the incident ray is passing through pole, you can say. So this will be your angle of incidence, right? This is there you will have center of curvature. So this will act your normal now. Now normal is just the point. Normal is the line that is joining the center of curvature with the point where incident ray is means touching this. So this is your normal here in this case, and angle of incidence is equals to angle of reflection. So quite simple, right? And for the concave mirror, so this is convex. For this, same thing. This is a pole, going to pole, angle of incidence, so that's your normal, and angle of reflection. So students, these are the 4 ray diagrams that I have made. So you need 2 rays. So any combination of these are the 4 ways in which incident ray behaves. Okay. So any 2 of these 4 you will need to draw the image formation. Okay. So note them down. And they are there in your book also. So now we have image formation. So this is this was topic 10.2.2, and you have all these 4 figures in your book also. So page number 164 and 165 of your NCRT. Now we have figure 10.7. So when you see figure 10.7, you also see table 10.1. So figure 10.7 you need to see along with table 10.1. And now I will see in figure A. I'm not going to, okay, if just open your books, those who have not opened. So students, this table 10.1 in your books. So just read this table. And you have this figure 10.7. So put these 2 things together to understand. Now here, which 2 rays we have taken in this diagram? So this is the first, the object is at infinity, and the rays, so 2 incident rays we have taken. First one parallel to the principal axis and then passing through the focus, and the second one I have taken passing to the center of curvature and going back from the center of curvature. So for this diagram I have taken this ray 1 and this ray 3. Okay, and you will have the image at focus. So meet at least 2 incident ray. So here I have taken in fact 3 rays, 1, 2 and 3. So 2 of the rays are parallel to the principal axis and 1 is passing through center of curvature. So this one is going back and this is, so you need 2 rays. Okay, Now what about this? Now I am bringing this, what I will do, I will bring this object near to the mirror. This is what I am going to do. Okay, now I am bringing it not at infinite distance but at a finite distance, and which is beyond C. So see, beyond C. So the image will be moving away from the mirror. You can see that as I move the object towards the mirror, this image which was at focus is moved away, and its size is also increasing. Okay, now I am taking the object more near to the mirror at C. See, the size of the image is increased more, and it is of the same size as object. Now taking the image more near to the mirror, the image is moving away from the mirror, and now it has gone beyond C. Okay, taking the object now at focus, the image is at infinity. Now taking the object more near, means between the focus and the pole, the image, you can't take it on screen now, the image is behind the mirror. So in these 5 cases the image was in front of the mirror, so that is why it was real, you can take it on the screen. But this image is behind the mirror, you cannot take it on the screen, and this image is the virtual image. You can see all the real images are inverted. All the real images are inverted. Even the image which is made by our eye lens is also inverted and real. Okay, so but if the object is between the focus and the principal axis, then only the image will be virtual, and it is erect. Erect means seedhi, inverted means ulti. So when the image is real, it will always be inverted, and when the image is virtual behind the mirror, virtual image will be behind the mirror, it will be erect. Now as we are moving the object near to the mirror, the image is moving, position is, image is moving away from the mirror, its size is increasing. Okay, so this is what these ray diagrams are about. Here which 2 rays you have taken in this diagram? Parallel to principal axis and passing through the center of curvature. Parallel to the principal axis, passing through focus. Another ray passing through center of curvature, going back, angle of incidence is equal to angle of reflection equals to 0 here. And the 2 rays where these 2 reflecting rays are meet, so we have this image formation over here. So here 2 rays are meeting, 2 reflecting rays. Here the 2 reflecting rays are meeting over here. So which 2 rays we have taken? One parallel to the principal axis, passing through focus. Another one is going through center of curvature and coming back. So here also through center of curvature and going back. So, and what 2 incident rays you have taken? Parallel to principal axis, passing through focus, going through center of curvature, coming back through center of curvature. Here center of curvature one, and you can take the image. So this was the last case that we were discussing, the image meeting through focus, the incident ray means incident, it is incident on the pole, then obliquely, so then this will be the reflected ray. So it appears that it is coming from this point. So that's how the image formation takes place, students. And now for the, you have, this was for concave mirror, and similarly we can have the image formation by the convex mirror also. So for that you need to see table 10.2 and figure 10.8. So look at these figures. So now here we will have only two cases, because in front of mirror, because the focus and center of curvature, they are behind the mirror. So we have only two cases. The object is at infinity and the object is at a finite distance. When the object is at infinity, where all the rays which are coming parallel will appear to pass through focus. Same was the case with concave mirror also, and they pass through the focus because at that point, and the sun of means image of sun we have discussed. So here again the same thing is that this is the common point. There the image was in concave mirror, image was in front. Here the image is at the behind the mirror, and this is the common thing, the highly diminished point size image in both the cases. But here, there the image was real and inverted. Now here behind always the image is virtual and direct. Now at a finite distance, this ray going through center of curvature appears to go through center of curvature and reflecting back appear to come from the center of curvature. Parallel to principal axis appear to come from the focus. So these two rays, and so again these two rays are meeting at a point which is behind the mirror. So image here is diminished, so lesser than the size of the object, but both the cases the image is behind the mirror, so in both the cases the image is virtual and direct. So by convex mirror the images will always be virtual and direct. So students, that was all about the spherical mirrors. Now the next thing is that you have the formula by which you can exactly tell the distance of the image. So for that you have certain rules and mirror formula which is there. Figure 10.9 you can see. So students, look at this figure 10.9 in your books. So we have the mirror formula. So what are the sign conventions that we need to take? Students, first thing is that you always have to start whenever you want to know the size of the you want to know the position of the object, position of the image. You always have to start moving from pole. Okay, so now if you have your object over here, start moving from pole to B. Okay, are you moving in the direction of the light? This is the direction of the light in which, or are you moving in the direction of light away from the direction of the light? So if you are moving in the direction of light, so then that distance will be taken positive, and if you are moving opposite to the direction of the light, then that distance will be taken negative. So if it is such a simple thing, you always have to stand at the pole. So stand at the pole. Now object is here, so you will always be moving from plane to, means from the pole to the object. Okay, now in which direction you are moving? Rays are going from left to right, but you are moving from right to left. That is why object distance will always be negative. And if the image will also be in front, it will also be negative distance. And focus is always there in case of the uh, concave mirror. So focus will always be positive, focus will always be negative, image distance means the object distance will always, so these two things will always be negative. Focal length and object. So in the case of concave mirror, you will have U as always negative, focal length as always negative, and the image distance, which is by V, if the image is in front, that is real image, then it will also be negative distance. But if the image is behind the mirror, virtual, it will be positive. If the image is here, so you are moving from pole to this point. So if the image is behind, so then you are moving in the direction of the light, right? So that this direction of light is positive. One more thing you can assume, that this is your coordinate plane and xy plane, you can say. So this is x-axis, this is y-axis. This is your pole, which is your origin, and this is your negative x-axis. This is negative y. So if you are moving from here in this direction, it will be positive. If you are moving from pole in this direction, it will be negative distance. If you are moving upward, it will be positive. If you are moving downward, it will be negative. So students at pole, assume this as negative axis and this as positive axis. Because here the direction of light is this. So direction of light is this. That is why I can take this. And this upward, if the object is up, then this distance is positive, height positive, and if it is down, then this will be negative. So students, this is how these are the Cartesian sign conventions for the spherical mirrors. So in case of the convex mirror, so you know that in case of convex mirror, you have the focus point over here. So, but object will always be on this side. So this distance you will be moving, this distance will be negative. So this will again be negative, U will be negative in all the cases, whether it is concave or convex. What about the focal length? Focal length will be positive for the convex mirror. Okay students, and this what about the image? V, the distance V, it will always be, so as the image will always be virtual, so you will be moving on this side to measure the image distance, so it will always be positive. So for concave mirror and convex mirror, object distance will always be positive. For concave mirror, so if there is something in front, that distance you will be moving in the against the direction of light, that will be negative. So I hope you have understood this. And now we have magnification of the image. So we have two formulas for that, which is there in your book also. So look at equation 10.2 and equation 10.3. So these are the formulas for the magnification. So it is height of the object, which is your base, and this is the height of the image. So height of the image upon height of the object. I have told if you are moving up, so object will always be positive. So the height of object will always be positive. This will always be positive. What about h dash? So h dash, if the image is real, so if the image is real, so then it will be negative, and if the image is virtual and direct, so if the image is real and inverted, you will, this is, so you will be moving down from the pole. So that sign convention I have taken negative, so negative y-axis, and if the image is virtual and direct, then this h dash will be, so if the image is direct or virtual, so then it will be positive. So students, these are the formulas for the magnification and image. So your homework is example 10.1, 10.2, and you have 2 questions. So I hope you will be able to do these questions. Okay, still, if you want the questions to be discussed, let me discuss with you. So example 10.1, so how to do a numerical. A convex mirror, so always whenever you have this numerical, try to draw the figure if it is possible. So you have a convex mirror, so this is the convex mirror. So you have this mirror as rear, means as rear mirror in your cars. So that is convex mirror. It is not a plane one. And the radius of curvature is 3 meters. So this is the radius of curvature. This is C. This is radius of curvature. That is equals to 3 meters. Good. So focal length is half of it. So what will the focal length? It will be 3 by 2 meters, right? Now, if a bus is located at 5 meters from this mirror, so we have a bus over here, which is at a distance 5 meters. Find the position, nature, and size of the image. So, first of all, we have to write the mirror formula. 1 by V plus 1 by U equals to 1 by F. Okay. Now, write the sign conventions here. This is the direction of light. So this direction is taken as positive. So this direction is taken as positive, means the positive x-axis. This is your pole. And if you are moving in this direction is negative, negative x-axis. Upward, y-axis take as positive, downward, negative. So students, you have to make this diagram and this axis before start solving the numerical. So don't be in a hurry. Draw these things and then start doing your numerical. So here you have to find everything about the image. Okay. So what about U? U is on this side, so we will be moving from the pole to this side, means from the pole here to this side, against the direction of the light. This is the direction of light. So I'm moving away from the direction of light. So this distance will be -5. So 5 is over here. So this, you will write it as -5. And then you need focal length. So focal length is over here, 3 by 2 meters. So this is on this side, 1.5 meters. So draw them on the axis, okay? And this is plus 1.25. So that's your focal length, plus 1.5 meters. So students, you won't have any problems if you will do like this. So simply put the values what do you get? You get 1 by V plus 1 by minus 5 is equals to 1 by 1.5, or you can write 3 by 2 also. That's the same thing. So 3 by 2. So it will become 1 by V minus 1 by 5 is equals to 2 by 3. And 1 by V is equals to this minus, so that will be positive, or adding 1 by 5 both sides. So this comes out to the LCM is 15. So multiply 5, 10, multiplying 3. So this is 13 upon 15. So what's the value of V? V will be 15 upon 13. So this is 1.15 meter. So I already know the answer, because for concave mirrors I always have the image behind the mirror. So this is positive. So this is where your image is. So this is 1.15. This is where your image is at a distance 1.15. So students, then you need to tally it. So that's how you are enjoying the numericals. Simply putting the values is not going to help you. What is your answer? Then mark it in your figure. Now the magnification. Let us talk about magnification. So what is the formula of magnification? See, in comparison to the object is our base and this is our image, okay? So as you know that the image is behind the mirror, obviously it is erect, virtual and erect. Let us find it out from here. What magnification, we already know it is diminished. It will be diminished. And this H and H dash, now we don't know H and H dash here, but we know U and V. So if you know U and V, we can use that formula of U and V. So what is V here? We have just calculated. This is V is plus 1.15 divided by, what is U? So U is minus 5. So students, just this negative sign, place it outside and put them value of U and V in the brackets, just like I have done. So solve all the numericals like I am solving and you won't have any problem. Now this negative sign will cancel out and this will be 1.15 upon 5. So this will be 0.23. So this is positive. So it means that H dash upon H is equals to 0.23. Right? This is what magnification is. And this means that H dash is equals to 0.23 into H. So the image is, so this is the height of the object, and multiply the height of the object with 0.23 and you will get the height of the image. So obviously multiplying with a number lesser than 1, this is lesser than, so H dash is less than H dash. So the image is, you can clearly see the image is behind, so it will be virtual and erect. So from here we came to know that this is behind. Positive means behind the mirror. So behind the mirror means what? The image is virtual, image is erect
and diminished.
Okay, so this is what we came to know from this positive sign, and from here we have seen that it is smaller in size. So from here we have analyzed that is the image is smaller in size. Okay, and by factor 0.23. So this was your example 10.1. Let us do one more example 10.2. So this is an example of concave mirror. So I told you the first thing that you need to do is Take the diagram of the concave mirror. So this is a concave mirror. And the second thing you need to draw is coordinate axis. So this is plus x, this is minus x, plus y, and minus y. So this is your pole, this point P here, and this is your principal axis, which you can take it as x-axis. So this is what you need to do before solving the question. The object 4 centimeter in size. So the size of the object is 4 centimeter. 4 centimeter, change it into okay, let it be centimeter. So if you are taking in centimeters, so all the dimensions are supposed to be in centimeter only. Okay, let it be 4 centimeter. Okay, is placed at 25 centimeter in front of the concave mirror. Okay, so this distance is 25 centimeter. This is 4 centimeter, the height of the object. Okay, in front of a concave mirror of focal length 15. So focal length is 15. So this is my focus, and this length is 15 centimeter. At what distance from the mirror should a screen be placed to obtain it? So obviously we are placing the screen, so it means the image is real and inverted. So I want a sharp image. So same question as above, we need to tell V here. Such a simple question. So this is, draw this 4 centimeters, so upward direction, so this 4 is positive, this 15 is on this side, so this side negative x-axis, so minus 15 centimeter, this again on the negative side, so this is again minus 25 centimeter. So minus 15 is your focal length, minus 25 is your u. So another formula, 1 by v plus 1 by u is equals to 1 by f. So v you need to calculate, u is equals to minus 25 centimeter and f is equals to minus 15 centimeter. So what will be the v? 1 by v is equals to, you can also solve it numerically, means algebraically, sorry. So like 1 by v is equals to 1 by f minus 1 by u. So that's equals to 1 upon minus 15 minus 1 upon minus 25. And this will be equals to 1 upon 15 minus 1 upon 15 plus, so this minus minus will become plus 1 upon 25. So now the LCM will be, will it be 150? Okay. So 150, this will be minus 10 and this will be plus 6. So this is equals to minus 4 upon 150, and this will comes out to be 2 and 75. So v equals to, so this is 1 by v. So this is what 1 by v is, right? So you have calculated 1 by v is equals to minus 2 by 75. So it means v is equals to minus 75 by 2, and that is minus 37.5 centimeter. So students, all these units are supposed to be same. Okay, so here you have your image. So that is here at this point. So obviously it is real, it is inverted. So this is at a distance. So this distance is minus 37.5 centimeter. Okay, so whatever you have calculated in the numerical, then find its significance Now, what will the magnification? So magnification is h dash upon h, that is equals to minus v by u. Now, here you can do as you have done earlier, that you find the magnification with this formula, v, put the value of v and u, you find magnification, and then you can find h dash by simply multiplying it with the h, or you can simply use this equation also. So you have 4 variables, 3 are given to you. So in this question, the advantage is you have given h dash. So this is 4. So y-axis along you are moving, so positive direction, so plus 4. So you have h is equals to plus 4 centimeter. So now put the, so you need to calculate h dash. So simply put the values of v, u and h. So you get h dash is equals to h, so multiply, h will go that side and it will multiply. So minus v by u into h, and that will be equals to minus. So what is v? Minus 37.5 divided, what is u? U is also negative, minus 25 centimeter. Multiply by, what is h? H is also plus 4 centimeter. So this will comes out to be, so this negative will cancel out, but still you have one more negative. So the answer will be negative. And when you will solve it, it will comes out to be minus 6 centimeters. So it means this, the image you will have is, this is the image you have at a distance minus 37.5, and it is 6 centimeter. So it was 4 and it is 6. So it is 1.5 times enlarged. You can clearly see. So the image is, this negative thing is telling you that the image is actually inverted.
And enlarged.
So this negative sign is telling you that the image is inverted, and if it is inverted, it is real also. So this was again, this negative sign was also telling you, this v is negative means it was in front of the mirror. So this was telling you in front of mirror, this negative sign. So students, you need to understand the sign, negative and positive meaning in physics. Whenever you will study physics, you need to be very particular about what the meaning of this sign. So this negative sign means that the image is in front of the mirror, and if it is in the front of the mirror, you can take it on the screen and it is real and inverted. So from here also you are getting the hint that it is real and inverted, and this negative also means that the image is inverted, and if it is inverted, then it is real. So it means real and inverted. And what does this 6 telling you? 6, the size of the object was 4 and the size of the image is 6. So obviously the image is 1.5 times enlarged. So students, do the numericals always the way I have explained, okay? And further, I will put this video on the YouTube also, so that you can watch it again and again whenever you need to understand this concept. And those who have missed the classes, they can also watch this video on the YouTube channel of your school. So I'll post the link and you can watch it.